You've got a potentially viable data source. Time to go grab it and take a look around. Clicking on the data link on the main AHS page gives you a few options. Let's start by taking a look at the link to the 2015 National Public Use File, which sends you to a page with a whole bunch of options. For this course, we're going to just focus on using basic data files like the CSV file, the second link under the National PUF Files header. CSV stands for comma-separated values, and is a standard format used to store tabular data, such as what you'd find in an Excel spreadsheet. We're also going to presume you are used to downloading files from the internet and knowing where to find them on your computer. So go ahead, click that second link called AHS 2015 National PUF version 1.3 CSV. It might take a few minutes to download. Go ahead and hit pause here, grab something to eat or drink, and head on back when you're ready. You'll see that the file downloaded as a zip file, and when you click to unzip it, there's 3 different CSV files in there. Go ahead and open the household CSV file, which will open it in Excel. Wow, that's a lot of data, but don't panic. Data analysts run across this situation all the time. In your job, you're going to encounter data sets that are very large and also possibly incomplete, possibly incomprehensible because their rows and columns and data fields are in acronyms or abbreviations that you don't understand. You won't know who put it together or where it came from or access to who put it together. Your job as a data analyst is not to decipher all those issues, but instead to decide what value is contained in there and what can be done with it. Sometimes you need to do a little detective work, starting with asking colleagues if you can. Asking for help is a critical analysis skill. Beyond that, if you're lucky, many data sources provide additional supporting information about their data sets. For the purposes of this course, though, we're going to narrow things down and provide a more manageable example data set for you to work with. But please do feel free to dig around the AHS data. That's what any good data analyst would do. Scroll to the bottom of this page to download the Socrata example data.csv file. When you open that up, you should see something very much like this. At this point, it's incredibly useful to take a tour of the data, making sure you understand all the headers, the values, and starting to get a feel for the data. In particular, you're looking for missing or potentially strange values, or other indicators of the cleanliness of your data. This example we've given you is unusual for many data sources you might get. The headers are relatively clear, the data don't have missing values or strange characters, and so on. This would be considered very clean data, so what about dirty data? A detailed walkthrough of how to clean your data is beyond the scope of this course, but we will point out the many ways in which data can be incomplete, inaccurate, or corrupted. Data wranglers often spend a majority of their time cleaning data in order to make the downstream analyses go much more smoothly with more dependable, accurate results. In some cases, you may go through and clean your data manually, though if you're dealing with similar data sets from the same source repeatedly, you can write scripts or use other tools to make the cleaning process automated and repeatable. What really matters here is understanding why clean data matter. And a large part of this is because, as a data analyst, you're working with computers to do your analysis, and computers have specified ways of dealing with data. Let's take a closer look at what that means. Take a look again at the data you downloaded for this example. Try describing out loud what you're seeing. You might say something like, okay, there's a few headers here. It looks like the data tell me that for a given household ID, I can tell how old the building is, how long the current resident has been living there, and whether a smoke detector is installed. The catch is, you need your computer to understand the same information, and computers speak a very different language. Computers deal with information in specific structured ways that ultimately lend themselves to repetition. All data has some form or structure, but the structured data for computers means that the relationships between the data elements is explicitly reflected in the structure, or file format itself. That CSV file you downloaded and opened in Excel is one such example. Your computer will know to expect columns and rows with data in each cell. Other structured formats include XML, HTML, and JSON. These structured data formats are often referred to as machine readable. Compare that to a PDF, which is very human readable, but not easy for a computer to use for extracting and manipulating the data, or the text that it contains. Ultimately, you want to use machines to do a lot of the heavy lifting for your analysis, and they don't know or care if data are dirty or not. That's up to you. Before you move on to the next section, which will provide a much-needed lead on some good data, here's what you've already covered so far. You now know what kinds of data there are, that data analysis itself has its own discrete activities, and a few places to start looking for public data.